So Bismillahir Rahmanir Rahim. Bismillahir Rahmanir Rahim. So here is the problem, right? For the circuit shown in figure 1, find the load impedance ZL that absorbs the maximum average power. Calculate the maximum average power. So as I have described, this load impedance should be equal to the conjugate complex of Z Thevenin, and the P max is then found by the square of this magnitude of the Thevenin voltage divided by 8 times the R Thevenin. So we need to find out both the V Thevenin and Z Thevenin. So we need to find out the Thevenin equivalent circuit for this given circuit here across these terminals A and B where the load impedance is connected. So let's first redraw this circuit without this load impedance here. So this is 5 ohm, right? And these are terminals A and B where this load impedance will be connected. This is J10 ohm, this is 2 amperes, this is minus J4 ohm, and this is 8 ohms, right? Let's call this fig 2. So we need,
यार स्ट्रीम हो रही है कोई वीडियो वगैरह समझ कोई आ रही है मुझे तो नो वीडियो अवेलेबल ही मिल रहा है
are you able to see this stream?
नहीं आ रही
No stream? It's again.
यार बता दो सर को फिर के वो वीडियो नहीं हो रही शेयर ना लिखा हुआ अवेलेबल
Okay, just a minute. Are you able to see the stream? No?
नहीं सर कोई वीडियो शेयर नहीं हो रही ऑथेंटिकेशन एरर आ रहा है नहीं हो रही सर वीडियो शेयर
Okay, so it means there is a problem with the network then, right? So there absolutely no video? नहीं वो आप I think you are using the previous link. You must have used the new link that I have shared with you. The link at the bottom. Sent at 2:15.
वो यूज कर रहे हैं उस पे आ रहा है द वीडियो इज प्राइवेट अनअवेलेबल आ रहा है
No. That's the previous link. That is the previous link. Or the link which ends with KKK. It is the link that you have to use. This link is set as 2:15. The previous link was set as 2:04 p.m.
सर वही कर रहे हैं लिंक यूज वही यूज कर रहे हैं लिंक तो दिस वीडियो इज प्राइवेट आ रहा है
All right, let me check. All right. Okay. Are you able to see the stream now? Are you able to see the stream now?
जी सर अब हो रही है शेयर
But is it smooth? Are you able to see it? So we need to find out the Thevenin equivalent impedance and Thevenin equivalent voltage across these terminals A and B, right? So to find the Z Thevenin, we must turn off the independent sources. So we must turn off this independent source. Turn off the 2 ampere source. So to turn off this source, we need to open it, right? So the revised circuit is then given like this. This is 8 ohm, this is minus J4 ohm, and this is J 10 ohm, and this is 5 ohm, right? And these are terminals A and B, and let's call this fig 3. So we need to find the Thevenin impedance across these terminals A and B, and this is the circuit that we have found after turning off this 2 ampere source. So we see that this branch, there are two branches and both are these parallel, right? We just need to then found the equivalent impedance of these parallel branches, and that will then be the Thevenin equivalent impedance. So this is 8 ohm and plus J6 ohm minus J4. So let me just redraw. This is this branch, and then this is this 5 ohm, and this is cross terminals A and B, and this is 8 plus J6, 8 plus J6 ohm. So then Z Thevenin is given by, this is 5 in parallel with 8 plus J6. So Z Thevenin is given by 5 into 8 plus J6 divided by 5 and plus 8, that is 13 plus J6. So Z Thevenin is given by, we need to convert this into polar form. So shift or 8 and plus J6. This is 10. So 10 multiplied by 5 will be 50, and the angle will remain the same, that is 36.87 degrees divided by 13 plus J6. So that is 13 and this is 6, J6. So that is 14.32 at an angle of 24.77 degrees. So Z Thevenin is given by 50 divided by 14.32, that is 3.49, and the angle is 36.87 minus 24.77, that is 12.1 degrees, right? So this is the Thevenin equivalent impedance that we have found. So this Thevenin equivalent impedance, it can be expressed in rectangular form also. So Z Thevenin is equal to 3.49, and that is 12.1. So that is 3.412 and plus J 0.73. So ohms. So this is the Thevenin equivalent impedance. So the load must be equal to the conjugate complex of this impedance, right? So the load impedance ZL for maximum average power transfer, this load impedance must be equal to the conjugate complex of this Thevenin equivalent impedance. So ZL is equal to 3.49, and angle will be minus 12.1 degrees, right? Ohm, and that is basically equal to 3.412 minus J 0.73 ohm. So this is the value of the load impedance that will provide us the maximum average power. So the maximum average power is then given by P max is equal to V Thevenin square divided by 8 times R Thevenin. So now we also need to find the V Thevenin, right? To find V Thevenin, let's look at this circuit here again. So this is Thevenin voltage is the open circuit voltage across these terminals A and B, right? And if we look at this circuit carefully, there are two branches. When these terminals A and B are open, this 5 ohm resistance and J10 ohm reactance, these are both in series, and this branch 8 ohm and minus J4, this is in series. So if we find the current through this branch and then multiplied by 5 ohm resistance, then we can get the uh, Thevenin voltage across these terminals A and B. So let's call the current through this branch when these terminals are open, let it be I2. So I2 is given by using the current divider rule. So current, according to current divider rule, we 8 minus J4 divided by the sum of the impedances of these two branches. So 8 plus 5 is 13, and this is J10 minus J4, so that is plus J6, right? And multiplied by this total current 2 amperes. So I2 is given by, let's transform this into the polar form for the purpose of division. So this is 8 minus J4, right? So that is given by 8.94 at an angle of minus 26.565 degrees and divided by 13 plus J6. So that will be 14.31, and the angle is 24.78 degrees, and this whole term is multiplied by 2. So I2 is given by 2 multiplied by 8.94 divided by 14.31. That is 1.25, and the angle is minus 26. This angle minus this angle. So minus 26.565 minus 24.78. So that is minus 51.345 degrees amperes. So this is the current through this branch when these terminals A and B are open, right? And now the Thevenin is given by 5 times this current. So 5 multiplied by 1.25 minus 51.345 degrees. So Thevenin is equal to, so 1.25 multiplied by 5 should be should be 1.25 multiplied by 5, so that is 6.25. 6.25 angle minus 51.345 degrees force. Let's recheck again. 1.25 multiplied by 5, so that is 6.25. Yes, 6.25 volts. So this is the Thevenin voltage, right? So we have found the Thevenin voltage. Now we can just substitute the values here to find the maximum power. So P max is given by the V Thevenin square of the magnitude of V Thevenin divided by 8 times R Thevenin. So P max is given by, so the magnitude is given here, 6.25 is the magnitude of this Thevenin voltage. So 6.25 square divided by 8 times R Thevenin. You see, the Z Thevenin was equal to 3.412 plus J 0.73. So this 3.412 is the resistive part, right? And this is R Thevenin basically. So this is R Thevenin, and this value is to be used here, 8 times 6.412. So the P max is given by 6.25 square divided by uh, 8 times 3.412, right? So this is 1.43 watt. So this is the maximum power that is being transferred to this load here, this load, right? And this load is equal to this value 3.412 resistor part and minus j 0.73, which is the capacitive reactance here, right? So this load comprises of a resistance with value of 3.412 and a capacitive reactance with a value of 0.73 ohms, and the maximum power transferred to this load is approximately 1.43 watts, right? Do you have any questions? Any questions, students? Or we can discuss this offline.